Okay, so this is Integrated Math 2. We are in section 3-7, and we're on page 180. And we're doing homework problem 15 about clothing design. The figure at right is part of a clothing design pattern, and it has the following relationships. GC is perpendicular with AC. Line AB is perpendicular to line BC. Line AB, DE, and FG are all parallel to each other. The measure of angle A is 50 degrees. And triangle DEC is an isosceles with the base DC. Find the measure of all the numbered angles in the figure. So what I'm going to do before I even get started is I'm going to write down the numbers. So as we find them, we can write them in. All right, so there are 9 angles that we're going to try to find. So I've redrawn this picture of the triangles right here just so it's a little clearer. So I'm actually going to go ahead and scoot it up. Hopefully you have your book or you have a copy of that picture somewhere else. All right, so GC, that's this line here, is perpendicular to AC. So if that's true, then 3 plus 5 plus 6 is going to equal 90 degrees. Okay, because these two lines, this bottom line and this top line, are perpendicular. AB is perpendicular to BC. So AB is perpendicular to BC. So that makes this line, or excuse me, this angle a 90-degree angle. So we can actually go over here and say angle 4 is a 90-degree angle. So we have a bunch of parallel lines, which we're probably going to use corresponding angles or talk about those in a few minutes. Measure of angle A is 50 degrees. So if this is 50 degrees, if this is 50 and this is 90, then when we follow this triangle back, which I will grab a pencil and just sort of lightly highlight inside for you so you can kind of see what I'm talking about. Hopefully that showed up on the video. That makes 3. So angle 3 is going to be equal to 180 is the total, minus 90, minus 50, which equals 40 degrees. So angle 3 is equal to 40 degrees. All right, so we got 2 of them down. Let's move on to the next triangle. All right, so we see this triangle. We know that DEC was a isosceles triangle, so that means this side and this side are going to be the same. So angle 1 is equal, or I can use angle symbols here if you wanted. Angle 1 is equal to 3 plus 5, right? This space right here is going to be the same as this space right here. You can kind of see that. My triangles aren't perfect, but you can kind of see that, right? This triangle is going to be an isosceles triangle. All right, so we know what 3 is. We know that that's already 40 degrees. We don't know anything about 5, though. Well, let's do something different instead. Let's look at this small inside angle, or inside triangle. It's not an isosceles anymore. It's this triangle right here. So I'm looking at triangle DH and C. So angle 1, this angle right here, these two lines are parallel. They'll cross by the same angle. That makes this also a 90-degree angle. And by the way, that's going to be a 90-degree angle too. So that means that this angle is got to come to the same amount as that angle. In fact, if those two are parallel, 1 and A are a corresponding angle, and 2 and A, this is one line, and it's crossing 3 different parallel lines. Wow, we solved 2 more. All right, so we can say this is going to be a 50 degrees, and this is going to be 50 degrees. Well, that was cool. Okay, so 1 is 50 degrees, and it's equal to 40 plus something. 40 plus 10 is 50. That makes this 10 degrees. All right, for fun, I'm going to just cross off angles that we've gotten. So we did 4, we did 1, we didn't do 8. We don't know what 8 is yet. We'll solve it in just a second. We did 2, we did 3, we did 5. All right, well, we have 6 right here. So 3 was 40 degrees. 5 is 10 degrees. So 50, here I'll do it on top. 50 plus 6 equals 90 degrees. That makes 6 40 degrees, right? Algebra says. Okay. All right, so let's see, let's do angle 8. 1, this angle right here was 1, that's 50. 3 plus 5 was also 50. 50 and 50 is 100. So angle 8 is equal to 180 minus 100. So angle 8 is equal to 80 degrees. Right? Okay, so we got that one. All right, so what's left? 9 and 7. 7's up here, 9's down there. All right, so let's find a triangle that it fits into. Well, we have this triangle obviously right here, but we don't know what those two are, so that doesn't tell us a lot. Does 7 fit into any other triangles? If we look, 7 could actually be part of this big triangle, right? This one right here that I'm sort of highlighting. So we know what 2 is. We know what this is. This is 90 degrees. So that makes 7, can you still see? Yep. Is equal to 180 minus 90 degrees minus angle 2 is 50 degrees. So that makes it 40 degrees. 40. All right, and let's look for number 9. Number 9 is right here. So this inner triangle, number 9 is going to be where we have 7 plus 6 plus 9 is 180. So 9 is equal to 180 minus angle 7 minus angle 6. And angle 7 is 40 degrees and angle 6 is 40 degrees. So 9 is got to be equal to 100 degrees. All right, and that was part A. Suppose the measure of all the numbered angles, and find the measure of all the numbered angles in the figure. We just did that. Suppose AB equals FC. AB equals FC. This line is congruent to this line. Can you name all of the congruent triangles and explain how you can prove them congruent? All right, I'm going to stop the video here. I'm going to start a second video where we can prove that, okay? So that it's a little easier to upload.